Here's a bet I would win against almost anyone. Take a giant pile of real-world numbers. The population of every country, the length of every river, the price of every stock. Now look only at the first digit of each number, 1 through 9. Your intuition says they should be evenly spread, each digit showing up about 11% of the time. They are not. The digit 1 shows up about 30% of the time, almost a third, and the digit 9, less than 5%. This is Benford's law, and once you see it, you can't unsee it. Here's the actual pattern. If the numbers were random and even, every first digit would appear the same amount, about 11% each, a flat line. But real data doesn't do that. 1 leads about 30% of the time, 2 about 18, 3 around 12. And it keeps dropping all the way down to 9, which barely scrapes 4.6%. It's not a straight line, it's a curve that slides downhill every single time. There's even a clean formula behind it, but the shape is the part your brain refuses to accept. And here's what makes it eerie. This same lopsided pattern shows up almost everywhere you look. Country populations follow it, stock prices follow it, the lengths of rivers, the heights of mountains, the areas of lakes, physical constants in science, the numbers in your electricity bill, street addresses, even the file sizes on your computer. Wildly different things, with nothing in common, all leaning on the digit 1 in the exact same way. So what could possibly connect all of them? The secret is how numbers grow. Most real-world quantities don't grow by adding, they grow by multiplying, by percentages. Think about a number climbing from 100 upward. To get from 100 to 200, it has to double, a 100% jump. But to get from 800 to 900 is only a 12% step. So a growing number spends a long, slow stretch with 1 as its leading digit and races through the 9s. Over time, it simply lives in the 1s far more than the 9s. Stretch that across millions of data points, and Benford's law appears. Now for the useful part. If genuine data obeys Benford's law, what about fake data? When people invent numbers on a tax return, in cooked accounting books, in faked research, they tend to spread the first digits out evenly because that feels random to a human. But real data isn't evenly spread. So the fabricated numbers fail the Benford test and they stick out like a fingerprint. Auditors and tax agencies genuinely use this. A liar's intuition about randomness is exactly what gives them away. So that's 7. Your intuition has now lost to a birthday, a goat, a stubborn 9, 3 flavors of infinity, and now to the quiet tyranny of the digit 1. Brain, 0, math, 7. And this is just the start of a new run. The hidden rules buried inside randomness. Next time, I'll drop needles on the floor completely at random and use where they land to calculate pi. No circles, just needles. Subscribe and watch your intuition lose again.